On to question number 3, we have x squared dy plus y times the value of x plus y dx equals to 0, wherein x is equals to 1 and y is equals to 1. So again, we have to rearrange our equation so that we can have dy over dx, because in solving this, we're going to need v is equals to y over x, our y is equals to x times v, and our dy over dx is equals to v plus x dv over dx. So let's rewrite our equation. That's x squared dy plus y times x plus y dx is equals to 0. So we can rearrange this. Dy over dx is equals to negative y times x plus y all over x squared. There. So let us plug in our values for v and dy over dx. So that's v plus x dv over dx is equals to negative xv times x plus xv all over x squared. So we can factor out x squared in the right side. So that's v plus x dv over dx is equals to negative x squared v times 1 plus v over x squared. So cancel out x, and moving our v from the left side to the right side, we have x dv over dx is equals to negative v times 1 plus v minus v, and this can be simplified as negative v minus v squared minus v, or negative v squared minus 2v. Putting all of the v's in the same side and all of the x in the same side, we have 1 over v squared plus 2v again, leaving our negative sign, minus dx over x. Now we cannot use substitution here because we do not have any v's in the numerator and the left side. So we are going to decompose this fraction so that we can integrate this much easier. First, we have to factor out our denominator first, and we can do that by putting our v in the outside. So that's v times the value of v plus 2 equals to negative dx over x. So again here, solving in the right side, right space area, that's 1 over v times v plus 2 is equals to a over v plus b over v plus 2. So multiplying both sides by v times v plus 2 to remove all the denominators, we have 1 is equals to v plus 2 times a plus vb. So we can let our v is equals to 0. We have 1 is equals to 0 plus 2 times a plus 0. That's 1 is equals to 2a. So our a is equals to 1/2. We can let again our v is equals to 1. That's 1 is equals to 1 plus 2 times 1/2, because we know our value for a, that's 1/2, plus 1 times b. Therefore, that is 1 is equals to 3 over 2 plus b. Therefore, our b is equals to negative 1/2. Therefore, our 1 over v times v plus 2 is equals to 1/2 over v minus 1/2 over v plus 2. So putting that back to our main equation, that is integral of 1/2 over v minus 1/2 of v plus 2 dv is equals to negative dx over x. We can put our negative, our 1/2 on the outside because it's a constant. So that's 1/2 times 1 over v minus 1 over v plus 2 dv is equals to integral of negative dx over x. Therefore, we have 1/2 ln v minus ln v2 v plus 2 is equals to negative ln x plus c. This can be rewritten as ln v over v plus 2 raised to the power of 1/2 is equals to negative ln x plus c. Now, using both values on the left and right side as the exponent for e, in order to remove our ln, that is v over v plus 2 times v over v plus 2 raised to the power of 1/2 is equals to, you guys already know, this would equate to c times x to the power of negative 1. So this, or we can just write this as c over x. Now we can square both sides to remove the 1/2. That's v over v plus 2 is equals to c squared over x squared. So let's just erase this here. So that we have more space. So that's v over v plus 2 is equals to c squared over x squared. Now we can put back our value for y over x. So rv, that's y over x all over y over x plus 2 is equals to, our c squared is simply, again, is equals to c because it's a constant. That's x squared. So multiplying our x squared to the left side, we have yx all over y over x plus 2 equals to c. And using our condition, wherein x is equals to 1 and y is equals to 1 to get our value for c, that's 1 times 1 all over 1 over 1 plus 2 is equals to c. And that is 1/3 is equals to c. So plugging in our value for c, that's x over y over x plus 2 is equals to 1/3. That's if we cross multiply, we can have 3yx equals to y over x plus 2. And we can equate this as 3yx minus y over x minus 2 is equals to 0. And this is our final answer. Okay, moving on to number 4. This is a problem, a word problem. If the marginal cost of producing x shoes is given by 3xy plus y squared dx plus x squared plus xy dy is equals to 0, and the total cost of producing a pair of shoes is given by $12, then find the total cost function. So again, let us write first our equation. That's 3xy plus y squared dx plus x squared plus xy dy is equals to 0. We can rewrite this as dy over dx is equals to negative 3xy plus y squared all over x squared plus xy. Again, our value for v is equals to y over x, and our y is equals to v times x, and our dy over dx is equals to v plus x dv over dx. So plugging in those values, we get v plus x dv over dx is equals to negative 3, negative times the value of 3x times vx plus vx squared all over x squared plus x times vx. You can simplify that. That's equals to negative 3vx squared plus v squared x squared all over x squared plus vx squared. Now we can factor out our x squared to simplify the equation. It's equals to negative x squared times the value of 3v plus v squared all over x squared times 1 plus v. Cancel out our x squared. And next, we're gonna put our v to the right side now. That's x dv over dx equals to negative 3v, distributing our negative sign. It's negative 3v minus v squared over 1 plus v minus v. That is x dv over dx is equals to 1 plus v in the denominator, and in the numerator that's negative 3v minus v squared minus v squared. X dv over dx equals to negative 2v squared minus 4v all over 1 plus v. Now putting all of the v's in the left side and all of the x in the right side, we get 1 plus v over, again putting leaving our negative sign behind. In the right side we have 2v squared plus 4v dv is equals to a negative dx over x. So we can try and check if we can substitute the left side. That's u is equals to 2v squared plus 4v, and our du is equals to 4v plus 4. So yes, we can multiply both sides by 4 so that we can use u substitution. So that's 4 times 1 plus v, 2v squared plus 4v dv is equals to 4 times negative dx all over x. So that's 4 plus 4v all over 2v squared plus 4v dv is equals to negative 4 dx over x. And integrate both sides, we get ln 2v squared plus 4v is equals to, let's just that's negative 4 ln x plus c. And using both of the terms as exponent for the e so that we can get rid of our ln. Let's just continue here. So that is 2v squared plus 4v is equals to c times x raised to the power of negative 4. So we can input our value for v back. So that's 2 times y over x squared plus 4 y over x plus c over x to the power of 4. So that's 2y squared over x squared plus 4y over x is equals to c over x to the power of 4. And putting the x to the power of 4, multiplying it to the left side, we have 2 y squared x squared plus 4 y squared x cubed is equals to c. Now, in order to get our value for c, let us use our condition. It says here that the total cost of producing a pair of shoes is given by $12. Therefore, our x is equals to 2 because it's a pair, and our y is $12. So replace the value for x and y. We have 2 times 12 squared times 2 squared plus 4 times 12 times 2 cubed is equals to c. And our c is equals to 1536. So going back to our main equation, that's 2y squared x squared plus 4y x cubed is equals to 1536. Or we can simplify that further, that's y squared x squared plus 2y x cubed is equals to 768. And those are our final answers. Now moving on to our final problem here, number 5. The marginal revenue y of output q is given by the equation dy over dq is equals to q squared plus dy squared over 2qy. Find the total revenue function when output is 1 unit and revenue is $5. So let us rewrite our equation. That's dy over, that's dy over dq is equals to q squared plus 3y squared over 2qy. And then again, remember our v is equals to y over x, our y is equals to vx, and our dy over dx is equals to v plus x dx over, that's x dv over dx. Since in this case our independent variable is q, therefore let's just replace all of the x into q. So that's v plus q times dy over dq is equals to q squared plus 3 times y over q, y over q squared all over 2 times q times, this is not y over q, this is vq, vq, and in the denominator that's 2q times vq. Okay, so next, that's v plus q dy over dq is equals to q squared plus 3v squared q squared all over 2q squared v. So we can factor out our q squared. That's v plus q dy over dq is equals to q squared times 1 plus 3v squared all over q squared 2v. Cancel out our q squared. Next, so that's q, moving our v here to from the left to the right, that's q dy over dq is equals to 1 plus 3v squared over 2v minus v. So that's q dy over dq is equals to 1 plus 3v minus 2v squared all over 2v. Yeah. Oh, this is squared there. So we can simplify this. That's q dy over dq is equals to 1 plus v squared over 2v. Now, that looks ugly. Over 2v. And putting all of our v's in the same side and all the q in the same side, we get 2v over 1 plus v squared this is not dy, that's dv. So let's just pretend that all of the y's are dv. So that's dv is equals to dq all over q. And here we can actually employ u substitution for the integration of our left side, because 1 plus v squared, the first derivative of that is 2v. So integrating 2v over 1 plus v squared dv is equals to integral of dq over q, that is equals to ln 1 plus v squared is equals to ln q plus c. Now, using the left and right value as the exponent for e so that we can remove our ln. That's 1 plus v squared is equals to, let's just shortcut this, that's equals to c times q. So again, the reason why our c is multiplied by q because this can be this equation here can be rewritten as e ln q times e to the power of c, and since e to the power of c is a constant, that's just c. Okay, so going to the empty space here, that's 1 plus v squared is equals to cq. Plugging in our values for v, that's 1 plus square, that's 1 plus y over x squared is equals to cq. That's so our x is not x, that's supposed to be q. That's 1 plus y squared over q squared. Q squared is equals to cq. Now this can be written as q squared, that's q squared plus y squared all over q squared is equals to cq. Sorry. Now dividing both sides by q so that we will have only c in the right side. That's q squared plus y squared over q to the power of 3 is equals to c. And using our parameters before, if our output is 1 unit, the revenue is $5. So that's x equals to 1, y is equals to 5. So plugging those values in, so our q is equals to 1 and our y is equals to 5. So that's 1 squared plus 5 squared all over 1 cubed is equals to c. That's 1 plus 25 over 1 is equals to c, so our c is equals to 26. Therefore, our equation is now q squared plus y squared over q to the power of 3 is equals to 26. Or we can simplify that further, that's q squared plus y squared is equals to 26 q cubed. And putting all of our values in the left side, that's negative 26q cubed plus q squared plus y squared is equals to 0. And this is our final answer. So I hope you guys understood that and already know how to solve homogeneous differential equations. So that's all. So see you guys next time.